All right, everyone. So some of you we've seen recently in the US, some of you who did not see it then, and hopefully this is refreshing new information for all of you. As far as what we're going to what I really want to accomplish today is going into what a StoreNext file system-based solution offers to an end user, pretty basically. So architecturally, as our users are starting to look at whether it's in the media and entertainment space, how they're using SSDs, should they be putting them in a client or should they be putting them into a shared storage architecture? As our corporate users are looking at how they can use their shared storage systems for their block and their NAS environments, how can we accomplish delivering a consolidated storage solution to our users that currently may be buying their block storage from one company, NAS from 3 or 4 different companies, and as their data is growing, what is the best route to be able to accomplish consolidating that data? StoreNext as a file system is kind of a key technology underneath all of this, but I'll talk to you a little bit more about which markets that Quantum is currently targeting and why. So we started out as a company focusing in the media and entertainment space. We do, of course, have backup DXi customers and deduplication and tape libraries, but related to StoreNext, everything was initially optimized and designed around streaming media, streaming files extremely quickly. Not just streaming fast, but being able to ensure very high capture of never losing a frame. Our media customers are extremely sensitive to any sort of content loss, any sort of frame loss in their performance environments. And I'm going to talk through architecturally what we've done to be able to help accomplish that, while we also do nice things around data protection and that type of thing. As that type of use case where you have a rich media file coming off an instrument, a camera, a genomic sequencer, an automotive car has become much more common in the data center. These StoreNext-based solutions are very rapidly being adopted in these other use cases where there's a rich media component, that the data is a data-driven business where the data they're getting off of their autonomous vehicle for liability reasons, for example, is critical that you don't lose any bit of data coming off of a sensor, for example. In the genomics space, it's all about how these genomic sequencers are typically 10, 20, 30 million pounds to purchase. The storage system is a fraction of that. So how can the storage system never be the bottleneck to the expensive instrument? So all these architectural pieces that we originally designed for media and entertainment are starting to become really relevant across these other use cases. This is a little hard to read, I guess, up here. But there's a couple different challenges that we see our customers are starting to bump into. The first part is data is starting to outgrow traditional scale-out design. As a petabyte type of file system starts to get to 60, 70, 80% full, the performance drops significantly based on the way the file system handles a very full file system. On the other side, customers are starting to deal with running out of capacity. Their backup windows are too short to back up a petabyte of data, 500 terabytes of data. They're looking at all these new data sources that are coming in, and instead of having to have a dedicated system to each of the new sources of data where you have a dedicated NAS for your sensor data, one for your machine-generated cluster data, another for your user data, how can those IT departments manage that all in a consolidated type of system? And as you start to go through these, the traditional scale-out designs for scale-out NAS really aren't designed to be able to solve all these needs in a consolidated storage system, and that's really what StoreNext is designed to be able to do. So as far as how the data is used, and I'm going to get into the architectural pieces here very shortly. First, it's all about the speed of incoming data. In a data-driven business, typically whatever's generating the data, whether it's a 4K camera, it's a sequencer, it's a car, is significantly more expensive than the storage infrastructure. Anything the storage infrastructure can do to make sure that expensive data generating tool is able to be used optimally throughout the business day, throughout the work week, is the number one first job that we have with these environments. Secondly, you have retention of data. This is all about being able to keep a lot of data for a long time and be able to search the metadata, leverage the metadata in an effective way to be able to get value out of this data. And then data collaboration and sharing. Very often we see customers who are used to still even a direct attached storage environment where editing on workstations is done locally on direct attached storage, where data, once a project is completed, has to be shared across multiple different data centers. And in a traditional architecture where the inclination is to buy a few SSDs for your work systems, buy a NAS dedicated to each instrument, make copies of all that data up into the cloud. It's hard to manage, hard to keep track of, and you end up with 2, 3, 4 copies of data on all these discrete technologies. It leads to data sprawl, NAS sprawl. So consolidated infrastructure that can handle the performance, can retain the data cost effectively, and share it across geographies is really what StorNext is designed to do. As far as how it's being deployed, this idea of having a single high-performance system that can be used for user data is certainly optimized for being able to do high-performance, high-streaming data, large file content coming in at a very fast rate. But because of the way the metadata is isolated from the file data into the storage system, we absolutely can handle user data. We can handle mixed I/O, big file, small file in the same system. Small to medium-sized clusters, so maybe not the top 10 biggest supercomputers in the world. Typically those go to Lustre or something like that. But the medium-sized clusters that you're seeing in enterprises, financial services, the streaming and mixed I/O performance can again be shared with the user data, and then instrument capture data. That high resolution, never drop a frame type of content is really important. All that's coming into high performance file system. It can also be block, so as you look at these use cases where some customers want SAN, some want NAS, some have Mac clients, some have Linux clients, Windows clients, all of that is designed to be able to go into the single centralized data store. That centralized data store can be solid state disk, spinning disk, cloud, tape, object store, or any combination thereof. So as the data is all aggregated into this single namespace, what storage sits behind it can be our storage, it can be a public cloud, it can be somebody else's object storage. So being able to pull all of that data for simplicity of management, but also pull all of that data to be able to get information, query it, run analytics against it is really the goal of these types of systems. The types of solutions that are able to do this, StorNext, GPFS, the Spectrum Scale Solutions, and Lustre are really the 3 types of parallel file systems that are able to accomplish this kind of parallel simultaneous workload, can offer a single namespace. We're unique in that we offer both SAN and NAS connectivity, but being able to build in that data protection, the tiering, and the single namespace. Lustre does not do that.
Spectrum Scale does.
Spectrum does, but Lustre does not. Yeah. So as far as what StorNext is, just as a refresher before we go into some of the architectural details, it's 2 different things. Sometimes customers will implement us just for performance. A high performance parallel file system that you can have very fast concurrent 4K streams, for example, within a media and entertainment workload, very fast streams coming off a HPC cluster, for example. Shared access to the data. So the way we design it is you can have block data, you can have NAS data coming into the same system, and multiple clients can be working on the same file at the same time. Really, really important in these really big file types of environments where you have single copies. It's also really important where maybe you have somebody editing and then they're sharing that off to a post-production workhouse. And instead of having multiple copies of that same file on the editors and the clients, we can be able to share a single copy of that data in a single system instead of maintaining multiple copies of data. Within Storage Manager, effectively that's an HSM. So the file system has its own built-in HSM that can make copies of data. You can set retention policies for compliance. You can also manage your data sitting out within the cloud. So as cloud has become more and more important, what we're seeing is customers that are looking for, I want my cloud workload to be a part of my namespace. I have a high performance SSD tier, I have a cloud tier, but it's a single namespace for both of them. So seeing all of that data in a unified space is part of what Storage Manager accomplishes. So that's what StorNext is. As far as the architecture of it, it was originally designed as a SAN technology, fiber channel based initially. We now have, of course, support for single 10, 40 gig Ethernet networks for iSCSI, SMB type of connectivity. Within that box, you have your StoreNext clients. We have highly redundant, high-performance metadata. The metadata is written to SSD on a separate network from the file data. So we always keep metadata network separate from the storage data network to make sure we can maintain metadata performance, keep that isolated from the data that's coming into the system. We've added on several years ago the capability to also have the ability to connect to NAS clients. This is Windows, Linux, Mac, all the different types of clients offering NAS connectivity into that same shared storage environment. As we've been looking at that area, of course, there's different protocols going up to SMB3 that now are more high performant than a lot of the clients that were out there on the NFS side previously. Always focusing on maintaining performance as well as the compatibility with the Mac environment is important for our users. As far as sharing that SAN and LAN access to that single namespace has helped our customers who are starting to do a migration. We have a lot of customers who are still fiber channel based and are looking to start to move to a different kind of network architecture, and they're able to use a single system to be able to handle that migration. As that migration is done, the tiering is all done within our storage manager. So as tiering needs to come off of SSD to spinning disk to tape, that can all be done within the single unified system. And we can extend that now out to private clouds. So that's supporting things like CleverSafe, Scality, as well as our own object store Lattice, and then public clouds, Amazon Azure type of environments. So as this data is migrated, you can maintain the same copy of data on multiple different tiers. If you want to have 2 copies, 3 copies of your data, as customers are looking at how do you back up 500 terabytes, how do you back up a petabyte, a lot of them are starting to look at, well, maybe if I just keep 2 copies of my data, that's sufficient for my business continuity needs. Others will migrate a big chunk of the data, 80% of it, let's say, off of their high performance tier, and only back up their high performance tier. So the active data that's still changing in the user space, they'll leave up in a certain tier. They'll still run a Commvault backup on that piece, but everything else is migrated.
Are they relying on them using your metadata or somebody else's archiving software?
So in the StoreNext environment, they would be using our software. StoreNext, we call it Storage Manager, has all the policies that you can set: retention, types of data, affinity to different tiers of storage, affinity to different performance stripe groups within the environment.
Based only on age?
No, it can be file type, it can be usage.
Yeah.
So you keep a record of usage as well?
Correct, yeah.
Metadata.
Yeah.
And versioning as well. So if you wanted versioning, you can also determine that too.
So also, to that point, Tony, as you start to move that data back up, often a customer will use a certain set of data. They'll say a certain project has been moved off to cloud. When it's time to work on it, will be moved up to a higher performance tier, either user generated or based on the usage profiles that you're setting within the HSM. So the files of being able to move data up into SSD and back it down out of SSD, for example, as you're working on the project, is built into the system. Connecting to public and private cloud, that is a licensing model. So we have our appliances that we put on site, our scale-out appliances that manage all the on-premise tiering. When data is being pushed up into the cloud, we've designed that as a software-defined tier where, based on capacity utilization, a customer can shrink and grow their cloud usage so that they can look at, similar to how their cloud economics work, that they're able to shrink and grow their public cloud store. We can do the same. We offer integrated management, which Jason's going to be showing this later, to be able to show how much data is in each tier, at what rate is it growing, which departments are using that data. So you can use it for things like billing, you can do it for capacity planning, and you can also see across all my tiers of storage when I start to run out of capacity, instead of just buying another box and throwing it into the environment and kind of incrementally that grows, we can see the entire storage portfolio through that unified management. That includes, right now, Scality, CleverSafe, Storage Grid from NetApp, as well as our own tape libraries and our Lattice products. We are looking at what other hardware should we support, what other vendors should we support, but right now, this is new for Quantum that we've opened up. not just supporting our hardware within the StoreNext namespace, but being able to support other vendors as well. Okay, so Storage Manager, there's really, actually before I jump into that, I want to talk about Storage Manager policies. So there's part of what we do within the performance of StoreNext is all built around how we design the architecture. First, I mentioned we keep metadata separate from the file storage data. Separate networks, separate devices, ensuring that you can maintain metadata performance, you can have high availability, highly redundant metadata. So if you have multiple users working on the same file at the same time, we can guarantee it's not overwritten, we have a high availability copy. Within the architecture of StoreNext, we have something called stripe groups. So essentially you have LUNs that you can allocate what type of RAID you have per LUN. You can have RAID 1, RAID 6, however you want to handle your performance, your capacity built into these LUN groups. Then you have these stripe groups you put across the LUNs and can designate affinity for a certain type of file. A certain type of data will always go to the high performance group, or another type will go to the high capacity group. So even within a single stripe group and within a single storage tier, we have affinity based on how the RAID groups are set up. Then as the high watermarks, the policies are met, you start to migrate that data off to lower cost, lower performance tiers of data. So a lot is done within the file system to optimize your highest performance data for the right kind of availability, never dropping frames, the right kinds of performance, and then take advantage of lower cost tiers to get the economics you need for all these large capacity environments. Storage Manager, so this is our archive software. We do support other archive software. For example, if you're moving data off of an Isilon into a StoreNext environment and you need a way to get that data moved off the Isilon into our environment, we do support third-party tools that can do that type of work. Once the data is within our storage environment, we would use our own archive software. Really 3 different capabilities. I'm going to talk about each of these as far as what are the policies we can set so as the data is being moved. How do we use this to manage file system capacity? Make sure you have capacity in the most high performance tier. And then what can you do to protect the data as it's moved across the different tiers of storage? So first, the disk-to-disk relocation. I mentioned that we have the affinity groups built into the RAID system. So this idea that you have active data being edited goes into the highest performance data tier. You have other data that may be just streaming off a compute cluster, it's not being worked on, it's not being edited, and you just want to be able to have that into a streaming group that really is optimized for streaming performance. Once that data meets one of your high watermarks, you can truncate it, you can leave the file in 2 different locations, you can start to migrate in the background while keeping an active data tier up in the primary copy of the environment. There's a lot of different options that we have there. Related to truncation, well, essentially what we're accomplishing here is being able to have the space management, that you can remove files from the disk as it's being moved off so that you can keep your high performance data available. Those conditions can be set on an automated basis or per type of file basis. So a lot of the cases you'd say, I'm going to allocate a high performance user group, affinity group to my compute cluster, but my user data is always going to go to capacity, for example. So in these mixed use case environments, we can enlighten that. And you can either start to migrate all that data as the system gets full, or you can say, always my compute cluster data always is going to stay in the performance tier. My user data is the only data that's eligible to be migrated to lower capacity tiers of storage. The way this is all set up is into an appliance type of model. So as we've seen use cases such as automotive, the artificial intelligence, autonomous vehicles, scientific use cases, most of those guys don't really have IT people in their environment. They might have access to 1 or 2 IT guys, but managing these environments has become really difficult for them. Having 5 or 6 NAS boxes that they're using for different use cases that they don't know how to cluster together, making multiple copies of data for all their users so that all the users have access to the data because they don't know how to manage a shared file system, all are issues that these customers are starting to really bump into. So we've seen the need to make this into an appliance that's very easy to install, and as Jason goes through the demonstration, That's one of the key things we want to walk away from is there's a lot of cool technology in here, but it's also fiendishly complex. If you think about setting up 6 different types of RAID groups that are all being built into these affinity groups, and you have multiple tiers of storage that are connected over networks, and you can't figure out why the performance bottleneck is coming off your SSD to your spinning disk. Most of our users really don't have that kind of technical knowledge. So being able to make this into an appliance that's easy to install, easy to monitor, easy to report, and easy to troubleshoot has become a really important part of this. So we wanted to talk a little bit about what's going on inside the system, but also what makes it digestible to a traditional customer. So we have Axelis, which is our high-performance appliance. This is built in to compete, in the Isilon type of market. It's designed to compete against standalone GPFS spectrum scale types of environments, and is really the area where customers are looking for extremely high performance connecting to their instrument environment. It's designed to have lots of high availability in the metadata. It can have availability based into the data copy, so you can have multiple copies of data. It's designed to be able to configure where you can add performance and scale independently. So you can add performance to your metadata, you can add performance to your storage pools, and you can add capacity all independently. So as this system starts to grow and your user data, your instrument data start to grow, and you realize you're hitting performance bottlenecks for a certain client, we can allocate out more performance to that client or to that use case separately from needing to add capacity to the environment. So being able to have that scale out, scale up type of configuration is really, really important in this area, and high availability is really important. And then we also have this built into an archive gateway appliance. So designed from a hardware perspective for a lot less performance, but for that user who already has their primary high performance storage need solved, but still needs to manage huge amounts of data in multiple different technologies, maybe in multiple data centers. So all the things I've talked about from StorNext, from storage management, from a tiering perspective, we've also built into an archive gateway appliance. What that delivers to them is, 15, 20 years of HSM capabilities, managing copies, managing tape libraries, managing object stores, being able to move all that data, all these different tiers, and maintain that in a single namespace. There's been a lot of companies in the last few years who've been coming into this space saying we need a NAS front end to our tape library, we need a gateway appliance to manage multiple geographies. That's really the area that Artico is designed to solve, but it's designed to solve it being able to manage all those different tiers, including tape, in a single namespace, and designed to scale into billions and billions and billions of files.
Just before you go on, Molly.
Yeah.
It says scales from small environments to petabytes. How small? What's your definition of small? How big is it?
Yeah.
So the entry-level system, the disk cache will be around 46 terabytes.
Okay.
And then you can obviously attach to that the back end a tape library.
20 slots can start.
Yeah, 20 slots, so you can,
Okay.
you can start, you can start quite small.
Some terabytes to some
So as far as why tier, there's a lot of things that we could really touch on here. You can go into a lot of different topics on this. I'm going to start on the high performance side. When you start to look at SSDs, this is all about a petabyte of storage over 3 years. We used our pricing. This wasn't designed to sell for or against any technology. We support them all. So we aren't selling one of these tiers versus the other. But what we're first starting to see is instead of having users putting a lot of SSDs into their clients or into their standalone servers, being able to have a shared SSD pool gives them the ability to have one copy of data or 2 copies of data sitting in their SSDs instead of each client having their own copy. Christoph was talking about earlier today that we've done quite a few POCs where the customer says, well, I don't know, I'm worried about drop frames. Maybe you want to share that story.
Yeah, I mean, I think the most important thing to understand is, as you guys all know, there are different forms of technology available. So be it flash disk, be it SAS disk, there are all of these different types of technology, even object storage as an example. And the big issue for customers, particularly if we look at media entertainment, where they really push this technology to its nth degree, they worry terribly about being in a position where they're not going to be able to read a file. So a very good example is 4K video is very common now because the prices of cameras have come down. And there's a particular format called DPX. And really what this is for every single frame, there's a file. And if you think of something like Netflix, who would demand 28 frames per second, that means you're going to have 28 files per second. So the reality is it's very, very intensive. So our first encounter with a customer, we do a POC, particularly a post-production house, is I say, well, look, I really don't want to walk away from my edit suite not having its storage local, because I just can't afford to be in this position where I'm going to drop a frame. This is a critical aspect to me. So part of what we have to show them is that instead of having multiple machines and each machine having its terabyte or 10 terabytes or 20 terabytes worth of storage, we can give them the centralized storage, and then they can share that data. Because in the real world, and the term that a lot of vendors use is workflow, I'm sure you guys have heard this a million times, but in essence what it is that the first station is doing maybe some animation work, the second station is maybe doing color grading, and really all they're doing is they're taking this big file, or multiple files, and they're copying it from station to station. So the way we go and approach that is we say to them, well, look, what we can do for you is give you the centralized scenario, and we can save you that copying business, which is really this big word workflow. And it's as simple as that. It's not more complicated than that. But the real secret sauce, as Molly was alluding to, it's this ability to demonstrate this performance. And the performance is not necessarily straight line performance. It could be measured in latency, which is another thing that's coming up in the market at the moment. I hope that answered your question.
Yep. So as data comes in and customers starting to grapple with, should I go to Flash? What benefits is it going to offer to me? We're working on how do you optimize, these affinity groups for Flash so you can have the right data using your Flash, and the data who doesn't need it, it can go to other tiers within the environment. And then as the data starts to tier down, really where we're seeing the economics of kind of these right-hand tiers really making a difference is you have this big shared storage system. And if you just went with continuing to add more NAS nodes to your environment, it's kind of a fixed cost. You have to add the cost of performance, the cost of capacity is pretty linear. In a lot of these environments, they're starting to grow to become quite large. A scientific use case that we have is a automotive supplier up in the Nordics where it was a new autonomous vehicle project. They only had a couple million euros to spend. And if they went to their traditional NAS vendor, it was a project that would have cost them about $15 million. So it was more an issue of they couldn't do the work if they used traditional NAS. By leveraging the economics of an archive tier, in this case it was tape, they were able to get the capacity they needed for about 1.6 million euros and the performance they needed by having a dedicated Excelis box that was architected to meet their metadata and data file usage performance. So the tiering is less about which storage media, but how do you architect these solutions to be able to offer the performance they need for the data and the capacity they need within the budget that they have available. And traditional NAS vendors who don't support as many tiers, who don't have the capability to divide up performance and capacity and tiering, often just aren't able to compete in the business. On the broadcaster side, 4K has become very interesting. That 4K has been around for a while. We know about 4K cameras. I have a 4K TV, probably a bunch of you do as well. But that entire workflow as the data is streaming across and you're looking at how do I maintain performance across my entire 4K workflow from content creation to editing to distribution has actually taken some rewriting of the file system, optimization of how to leverage the SSDs, and the streaming performance that we've been able to create. We've only just come out with the blueprints, and in fact we're going to be talking about these at NAB this year, that we have a new appliance series that we're launching around 4K workflows because how you stream, how you architect, and how the data is written actually had to be a bit different to be able to maintain this kind of performance. People who have not architected properly for this, including StorNext until we did this work, really weren't able to drive the performance of a 4K environment. So that's new and it's really big to these users. I'm going to go through a couple of case studies. We talk about broadcast a lot because that's where the company came from. That's where the workflows needed this kind of performance as well as the tiering of data for capacity for a long time. But I mentioned that there's quite a few other markets rapidly adopting these StorNext-based solutions, so I wanted to talk about those a little bit as well. So Airbus, this is all about satellite data. Their satellite streams are bringing in more than a petabyte per year. That needs to be scaled over 15 years. All of that data has to be retained, and it has to be moved in a very high quality way as the data is being streamed off those satellites. Again, dropping frames, losing data is a critical issue that they absolutely have to design against. So being able to capture that data, they're archiving about 40,000 files a day. So lots of files, high file counts, and very valuable data. They're putting that all into a StoreNext-based solution that is managing our tape libraries. In this case, the data is moved out to the tape archives, and the disk cache is primarily used for streaming and capturing the data, and then moved immediately to the tape. The archive right now supports 18 petabytes of data, being able to capture data off of 4 satellites simultaneously, and then archive that data, designed to be able to grow, of course, over time. Right now, they need it's not super high performance. It's 1.1 gigabytes per second of data coming into the environment. So in this case, that having a locked performance to capacity ratio really didn't make sense. They needed about a gig a second, but they need petabytes of type of data. And we were able to design the solution so it was economically designed for that capacity without overdoing it on the performance side. Max Planck, so a different use case. Max Planck is using StoreNext-based solutions all around being able to offer the simultaneous access. So in this case, they wanted that shared file capability. Multiple users, multiple scientists being able to work on the same content. That's something that most traditional NAS systems don't do well. Most traditional block systems don't do well if they do it at all. And this for them was a really big deal about, they're collecting just about 100 terabytes a day, 80 gigs a day of data per day. Multiple scientists are working on it at the same time. And in this case, it stays high performance and it's shared data that they're really looking at getting out of the system. And then the last one, CWDG. This is really about taking advantage of the economics of integrated tiering. A lot of disk companies, and we can do it too, of course, are pretty good at moving data across SSD and spinning disk, but adding the economics of a tape tier that's available in a single file system so that you don't have to, many of you know I used to work at SpectraLogic. They have a great tool to be able to put a NAS front end to their tape library. However, they don't have that high performance side. Being able to have single namespace for high performance, archive and tape all the way off those tiers is really unique to the StoreNext-based solutions, and what customers often are wanting is not to have to move to a new NAS namespace, just be able to get data into their tape library. It's a good solution either way, but having a single NAS environment, a single environment instead of having to add more NAS nodes, whether they're disk or tape, maintains the simplicity of the environment. So with that, I'm going to hand things over to Jason, and he's going to go through a demo and walk through kind of emphasizing more the complexity of the technology and how we're abstracting it. It's not just putting it into nice hardware appliances that install easily, but the management, the reporting, and the debugging of the environment. He's going to walk through that in a demo of the Connect software.
Awesome. Thank you,
All
Molly.
right.
Yeah, very good. All right, let me just get this started.
So while Jason gets that started, another really interesting point that we're seeing in the market is lots of people want to adopt object storage. I mean, this is a big thing that people are talking about. So one of the things that our appliance does is it enables companies to use their existing applications and talk to an S3 HTTP REST protocol. And that's part of the magic that we're doing, right, is we're making that object storage look like a traditional NAS device. And in some of those examples that Molly was giving, those examples and why they adopted our technology, they're already using our tape, and they adopted our file system because they could then adopt object storage. So we're almost an accelerant to object storage, which is an important piece here. There you go, Jason. You ready?
Yeah, very good.
Good man.
Segue.
Yeah, good segue.
There you go.
So hi everyone, I'm Jason Corey. I'm a bit new to Quantum. I just joined about a month and a half ago. I come from the world of HPC. So I'm ramping up a bit on quantum technology. So
Ask lots of questions.
yeah, so feel free to ask lots of questions. And actually, unlike some of my countrymen and political leaders, there are no bad questions. I need just good questions. I respect the news media, so I don't see fake news, so please go ahead and ask questions, but I may need help from my colleagues here.
Did you have any alternative facts?
We can really think of that.
Who is the Kellyanne Conway? Well, we call her Kellyanne Conway. So yeah, one of the reasons that I joined Quantum is that I thought, I knew in the industry that Quantum really listened to our customers. And beyond the file system being tried and tested and a very reliable file system that was known for performance, one of our customers, not one, but many of our customers wanted a better tool to really monitor what was going on in these environments. As Molly mentioned, the environments are expanding. There's a lot of business concerns. When I look at IT, I think it's a great balancing act, right? It's a balancing act between the needs of the business and making sure they're keeping staff productive, whether that staff is editors or scientists or engineers, keeping those resources productive and balancing that against the needs of IT and the resources that IT environment has. And so a management console like this, like StorNext Connects, really provides visibility into what's going on in the ecosystem. It provides visibility in bottlenecks, provides visibility with performance, and also in volumes and capacity. So it's a great tool from that standpoint. The other thing that we've recognized is that there's a lot of storage admins out there that are completely tasked. They're running out of time. Again, the environments between the clients and the workflow directors or metadata controllers, the different tiers of storage and where those assets are, they need help. And this tool also helps them manage that environment. So deploying more quickly or upgrading more easily and trying to automate some of that is a real important functionality of StorNext Connect. So this is, and hopefully you guys can see most of this here. This is the homepage for StorNext Connect. With our solutions, we have a lot of out-of-the-box functionality. So when a customer gets one of our systems, they basically have a quick start guide, they have some credentials that they can log in, and once they register their environment, they come to this web GUI. And you can see we've got all sorts of different application tiles here. The main categories of interest here and kind of the main functional categories are either monitoring, managing, or discovering. One of the neat things that we've got as well is if you look, so as we continue to develop this tool, because we've put a lot of work into it over the past 6 months, we're going to be coming up with new apps. In fact, we have Utilization is one of our newest apps, which I'll take everyone through today. But it's very easy for us to go ahead and push out an update and for storage administrators to take advantage of whatever that new application can do for them.
Who develops these apps? Can people in business develop them, or is it Quantum?
It's Quantum. It's in-house development. This also provides a very easy way, obviously, to see whether or not your system is updated. And if just in case you are behind a firewall, you can go to our website, you can download the files, and then you can upload them locally, which would be right here in the Connect apps. So if we go back to kind of the application homepage, where everything starts is our monitor systems dashboard. This dashboard gives great visibility into volumes and capacity, how much of that volume is actually being used, and we break it out between primary storage and we have tape libraries as well. So, it's a clear view in this system. And by the way, we're in a test environment in Mendota Heights, which is in our engineering facility in Minnesota. It's obviously, it's not being that utilized right now. We have 3% of primary storage, with 13% of our tape libraries full. But you also know that within the data visualization, there's a lot of interactivity. And so we wanted to try to make these environments as simple as possible to really dig in if there is a problem, figure out where that problem is. So behind a lot of these screens, the functionality exists to where you can click in and you can find out more. So here on this system, I believe we have 8 volumes, so 8 file systems. And I can see that there's not a lot of data on any one of the volumes. Just in our file system 1 here, we've got 29% full, but again, if I was a storage administrator, I wouldn't be worried. I'd be very comfortable, obviously, right now. The other thing that we can do to make that person's life easier is we can set thresholds. So right now there's 8 that are 0% full to 75% full. But let's say I wanted to trigger at 50%. I could just put that in here. And then I would start to get notifications when those volumes were becoming full of 50%. I could set finally another tier
Why
of
doesn't
them.
anybody ever put a rate setting here? Like a threshold is pointless, right? Because if it's 50% full,
Right.
but I'm filling it up at a rate of a petabyte an hour and I've got 50 petabytes, that's actually the critical point. Not the fact that I've gone past 50%, but the fact that I'm filling it up and it's going to be expired in 30 minutes. Does that make sense?
So within
But you have two thresholds. You see,
Yeah.
we haven't put only one.
Yeah.
So you can, depending on the type of use case you have, that kind of.
It should be a predictive threshold.
So
Hang on,
you
all of
have
a
it
sudden
down to-
my
yeah.
threshold is ramped. My data consumption rate has suddenly increased 25 times.
Yeah.
That I care about.
Yeah.
The fact that it's gone over 50%, 60%, 70% doesn't matter at all.
Right.
Does
right.
that make sense?
It totally makes sense. You know, one way you could do it in this system is if you had a gate at 50 and another gate at 65.
Yeah.
If you put the gates quite close to one another, if I get
would
two
just- I
notifications
would
right
just
away.
ignore them because it's 50% full. That's the least of my problems. I've got to go home and cook dinner for the kids tonight. I don't care.
Right. But if you get another
It's pointless.
notification.
Thresholds are pointless. Right? The point is that in storage, what you want is, hang on, you're going to run out of storage in the next 4 hours if this continues.
Yeah.
so
Velocity.
one really important point that's maybe critical for you to understand with regards to that point is within StoreNext, what we're doing is we're creating multiple copies, right?
Yeah.
So we might make it a protection copy. So you might have one on the primary disk and one sitting on object storage, as an example. One of the key features that we have is called a truncation feature. And what that is when you hit what we call a waterfall watermark, which is what you're talking about, what we do very cleverly is we go and truncate those files because we know we've got another copy,
Yeah.
which secures that storage. And it's these kind of rule bases that you can set up within StoreNext itself.
Right.
And it's this ability to truncate quickly, which is give the storage back so you
Yeah.
can go feed your kids. You can go home and you're not going to run out of space.
I've got more important things to do than
Yeah.
worry about my storage.
Exactly,
Like feed
exactly.
the kids, you know.
So,
Yeah.
but, it's all about, understanding, like you say, how much you're ingesting. And that Airbus example that Molly gave, I mean, that's basically all the telemetry data coming from every Airbus that's flying around the world. And I love flying, so it's an interesting case study for me. And in that case, they just can't afford for that cache disk to fill up. Because if it fills up, they start ingesting. I mean, it just
It
stops.
stops ingesting data.
So it's that example. And how they get around that is they have a very low watermark for truncation.
Right.
And that's
Because
really
I'm working with a high performance compute and we're collecting 500 gigabytes of data from a single shot, single laser shot. They
Yeah.
shoot laser
Yeah.
laser light source out of Oxford.
Yeah.
And you get this massive amount of data that suddenly gets written to your
Yep.
array.
Yep.
And then they do things like do an MD5 hash over 500
Yep.
gigabyte data file, right?
Yep.
Line by line.
Yep.
So, and we get these problems where
Yep.
just so much data is being written, and the fact that the array can go from
Yep.
50% to 80% full in a day
Yeah.
is
Yeah.
the problem, not the fact that it's
Yep.
hit the
Yeah.
threshold.
Yeah.
And again, the other reason why Molly was referring to affinities, right?
Yeah.
This is where you create this affinity. Is you could say on an affinity it's going to go to this particular storage, but simultaneously it's going to go to another piece of storage.
Right.
So you almost spread that
So
data.
you
as
can
it
start
comes.
to
Yeah,
fan
exactly.
out.
Exactly. So almost as you're ingesting, you're spreading,
Yeah.
and because you're doing that, you basically get to
Yeah.
a situation where you can.
Because the other problem we've got
truncate.
is we're now writing to the array at over a terabit per second, and I can actually ingest
Did I
data.
give you my business card?
We're ingesting data so fast that we actually can't control
Yeah.
the space on the array,
Yeah.
kind of thing. So
Okay.
And that's the main
That's a
thing.
good point.
It's probably clear to you, but the idea of truncating versus migrating. So when you truncate, you're just doing a delete off that primary file system versus waiting to do the migrate.
yeah,
So if you have your policy set that starts truncate when you're at 20% or 15%,
You
it's
will
still
do that.
not
yes.
specifically.
I mean, it's not
performance,
hard, it's just
but
a little
it's
bit
a
of maths
big
in
deal to be
JavaScript.
able to
Yeah.
delete.
You know,
it.
it's not an enormous pain, but it's like
I think it's really good feedback, and it's something that I
And-
think. Go ahead, Krista.
Sorry, I just want to go back to your point because I think what really something that maybe I didn't come across is within the StoreNext file system, there is an API. So one of the things that we do is we form very close relationships with a lot of software vendors. And the idea of creating that relationship is exactly what you just said, which is you can actually script certain things to happen. So just going back to the media entertainment world, just as an example, there are tools that allow you to basically within those applications where we've worked together with the vendors, where they can push an icon and it says, okay, I'm pushing that icon, it must go to data X or Y. And they can do it. So there is that capability.
So they could set up,
Yes.
so they could track this kind of.
Oh,
absolutely. And
Yeah.
that's the beauty, right? So we sell more than just storage, we're actually selling an ecosystem. And I think that's important too.
So for example, in artificial intelligence, emerging market, new applications being developed, a couple of our ecosystem partners that we work really closely with, they're like OEM partners. They embed their application within Excelis. They've written to the API directly to control the right data going to the right area, and as they're learning more, they can modify it from their application side.
So particularly around that CCTV world, right? That's another classic outside of broadcast, where that integration is important.
So,
Jason.
good. Yeah.
So, because there are something in this dashboard that disturb me, because the real things for the storage is to get back the data for the user. It's not to have not just only ingest data.
Right.
And I don't see in how much time I get back a file to my PC.
I'll show you that.
That's
Right.
the point that
It's a great point. So I'll get into that on monitor performance. Yeah, obviously that's an
because
important part
for
of the
me
equation.
this vision is very still IT-centric vision. It's not business vision.
Right. Yep. And at the end of the day, it's about the business. So let me get into that because we've included this. This is the overall dashboard, but there's within the different applications in the monitor performance application, we do address that. So I'll get into that. And that was very good feedback and good alternative fact, Christo. So
No pressure.
so no, I think velocity data is an important thing that we could visualize in future applications. So on this dashboard, let me just conclude with the monitor systems. So we've got health monitoring as part of this dashboard. We've got two HA pairs in this instance. One of them is turned off, so that's the first one here. This is one of our Excelis workflow directors. The second one is active, and these dots right here indicate that green, all systems go, those are healthy. If it was degraded in any way, those dots would be yellow. That would mean something redundant has failed and it needs attention. If one of those was red, it would need attention immediately because it's not generating any IO.
Do you have some other way of showing that? Because clearly under most European laws you need an alternative to just red, green and yellow colour for access.
I'm colourblind.
Colourblindness, yeah. Accessibility.
I'm colourblind in red green. I can't tell the difference between the two colours when they're within a centimetre of each other.
Right.
So European law says you've got to have another way of showing that.
5% of people are colourblind to a greater or less degree in red green. And that's why a lot of red green dashboards don't work.
Yeah, it's a good point. I have to talk to our developers.
We alert them through SNMP. That's our alternative.
Then you go old school.
Don't think that works under European law.
Evolution will take care of that.
You need an alternative.
Yep.
Do not rely on
I
colour.
never knew I was colourblind until I was sitting in front of an operational dashboard and couldn't tell the difference. Literally.
Really?
Yeah. The,
Yeah.
the company doing the dashboard had shrunk them down to the point where the red green was juxtaposed. And I
Yeah.
can't see them.
Really?
They just turn off. They become two of the same colour.
I discovered it when I learned to play snooker.
Yeah.
Couldn't find the table points.
That was probably just because you're such a bad snooker player.
Couldn't see the point.
And then you could see two of everything, couldn't you, Alex?
No worries. So finally, from a health monitoring perspective, we have our storage arrays, and again, we can see which ones are fail, degrade, or optimal by color. So something that we'll look into in the future. But behind this, what I wanted to show here is we can actually click into one of these devices, and this will actually go into its own disk storage management utility, where we can configure it further and actually start making policies and data movement policies, etc. So the two are connected right now, and we intend actually to do some changes in the future, perhaps make more of this actually through just StorNext Connect in the future. The fifth widget that we have is a performance widget. So this is really high level, and one of the things
For
that
read and write.
thank you, God, for read and write. One of the things that you'll notice is that we can get really high level with this console, but we can also get really granular. This is an example of us being extremely high level. This is an aggregate performance across the whole environment. Like Eb said, this is both read and write. This environment is not being used that much. Obviously throughput is not really that impressive. Latency is low. That would be expected, and we only have about 4 clients. So you'll see we've got a link here for monitor performance, but that's also one of our core applications that I want to take you through.
So just one thing before you carry on.
Yeah.
You mentioned earlier that a lot of people administering these systems are not storage specialists. So do you actually have any good practice for them to follow? Because if you stick this in front of the non-storage specialist, they haven't got a clue what's on there.
Right.
It means nothing to them.
So we do blueprints and best practices by application. So autonomous vehicles versus 4K workflows versus an HPC cluster, it's going to be very different. So we work it out by what is the application managing the data, what is the system, and how best to optimize the storage system.
So do you actually have a shrunk down admin console for a non-specialist to use in particular verticals?
I think there's a distinction we need to make between non-specialist and something that has no idea about the IT concept. He must have some concept. We don't ask him to be a storage expert, but they all know about what storage means a little bit. They might not know about how to go configure SAN. They might not know how to fine-tune SAN. That's where this thing into play. He has to have some basics. We cannot take someone that only used, basically, I don't know.
So your earlier language was maybe a bit over-optimistic then?
No, because we don't ask you to be an expert. We don't ask you to be someone that know how to install the product to be able to
You
supervise it.
need an IT generalist with a solid understanding
I think
at
that's
some
right.
level of storage.
An understanding of storage, yeah. Would be an idea, correct.
That's a good way to phrase it. Yeah. Okay, so let's get into monitor performance, because I think outside of monitor systems, I believe that a storage administrator would spend a decent amount of time in here, because this is going to show what's going on, obviously, between the clients, our workflow directors, and Stripe groups, and where maybe a bottleneck might be. Where is that data, and is there any performance degradation on the client side? Maybe jobs are causing certain things to get out of whack. And so what we've got here is we've got 2 ways to look at this. So we can look at volumes to clients, and we can look at clients to volumes. So in this instance right here, let's go ahead and pick this workflow director, this file system. And from a time perspective, you can see we actually go from 1 hour all the way down to 3 years. Now, I know this test environment, so there's not much going on before the last week or so, I believe. So I'll just pick a week, and then we'll update that. Okay? So what we're going to see is both data I/O activity and metadata I/O activity. And I think probably a lot of administrators will be really interested to see how are volumes and what kind of client performance are they seeing. So what you'll see.
May I add something?
Yeah,
So this is really interesting for someone that might not be experts. Okay, he's working on his application, on his client, and he's not going fast enough for write or read. He doesn't know what's going on. It is my personal computer that is the bottleneck. Is it the network? Is it the storage on the back? He doesn't know. He has no idea.
But
So
it doesn't
this tool-
mind.
Huh?
It doesn't mind. What he wants is information
Yeah, he just
going from the database. It doesn't
Yeah.
mind that the network or the
He doesn't
whatever.
even know. He doesn't care. Say,
Right.
I'm getting slow. I cannot get my job done. So he's going to call his administrator, who might not be a storage expert. He's going to come here and look quickly. He's going to find out easily, is that a bottleneck coming from the storage? Or is simply the server that he's using that was running out of CPU or memory? So we can help him pinpoint exactly this bottleneck where it is.
You can pinpoint that it's not in the storage or where in the storage, but you
Not
can't pinpoint
pinpoint
anything
storage
else.
or network.
You need a completely different set of performance monitoring tools for that. And trust me, I was evangelizing this 20 years ago.
You've got different panes of glass that you're going to have to
keep
go
in
through.
mind,
to
we
get-
have a storage client running on the server.
Right.
So we can go, we're not just a storage that's sitting on the back, We can go all the way to the server and see all the data path and see where it is. Is the bottleneck coming from the server client?
You're still just in the back end.
Yeah, if it's the application that's been
Oh,
written wrongly,
Yeah,
and so that's got to
you're
be.
only
That's
looking
the
at a
problem.
tiny part of it. So
Wait.
again, over-exaggerating use of language. Absolutes don't work with this group unless you can justify them.
Absolutely.
So with this, just can I share something that maybe might address what you're saying, and perhaps it doesn't, so you could help me get there. So right now we've gone from the client view. So if there's an issue on the client side, from this perspective, we can pick that specific client. So this environment only has 4 clients, but if you're in a real environment, you could have obviously many more than this. But I could hone into that client, and I could see, is there any problem between that client and a specific volume, right? Specific file system. In this instance, I can see that actually this client is really only utilizing the first file system 1. But the data throughput, the performance seems fine, and the latency seems fine. If there was an issue with that specific client, we would see it in one of these graphs.
Yeah, for the storage packet. Yeah.
But what would that actually tell you? Because between the storage and the actual client, you've got various things. It could be back-end array which is overloaded. It could be your network. It could be having lots of fiber issues. It really depends. It tells you it's running slowly.
Right.
It doesn't actually tell me where it's running slowly, so it doesn't allow me to do my RCA and fix the problem quickly.
So as you start to add different tiers, that's where it becomes most critical. You'll see, okay, it's
Yeah.
as it's moving from the SSD tier to the tape, all of a sudden I'm losing performance. Or it's from the client to the server. So it helps you hone down in a tiered storage environment which area to look at, but specifically which component. It helps get you in the right area in these complex
Yeah.
tiered environments.
So-
So it's more designed for, you've got 4 tiers, 4 different infrastructures, and you have somewhere that the data movement is slowing down. How do you handle that? That type of thing.
So maybe a piece that is important and might help clarify is we talked about stripe groups and we talked about affinities and having affinities to stripe groups. You can also have an affinity to a particular station or a particular server. So in the case where you're ingesting from a particular machine and you associate that to an affinity and in turn associate that to a stripe group, that's what that's doing. So the reality is you'll know exactly which server that's coming from. That's how it's known. So in your case, with that high ingestion happening from 2 or 3 machines because they're doing this laser photography, you'd be able to basically say, well, that's what's causing my problem because they are linked to a stripe group and they are linked to an affinity. That's how this works.
Okay. And you can have also multiple server rights in the same storage. Maybe there is something going on wrong with one server, it's like eating a lot of bandwidth.
Yeah.
You can also pinpoint that because it's affecting the other ones.
Yeah. And what that's recording, right, is how many megabytes per second it's writing on the one side, and then the other side is it's recording the latency. So I hope that addresses the absolutes.
We're absolutely certain we're not sure.
I'm absolutely certain I am sure.
So obviously it provides some clarity, you know, this is an ongoing process, right? So we can continue to develop this as we get customer feedback. The other, so let me go to a different app now. So this is Monitor Performance. I think everyone feels comfortable what this is, and providing really good visibility for storage administrators. And but let's go back.
Is there something behind each of the graphs in there as well? There are multiple levels behind it.
Besides being able to choose the workspaces and volumes, and then, you know, what kind of performance, or, you know, where you want to look at that performance.
The granularity is really done in the drop down on what you're looking at.
Yeah.
So actually, what is the back-end stored for these performance figures? So where, if I wanted to actually not use your front end, because I want to actually put it into my own monitoring tool, I want to move it into Elasticsearch, something like that. So how can I query your back end?
We use web services.
Okay.
And again, you could use the API behind that to feed.
Yeah, it's cool.
Yeah, these are basically outputs, And then from an interactive standpoint, if I want to zoom into something specific that's happening, I can do that down here. Yeah.
Do you have the idea to combine all this monitoring in a cloud service from all your customers' environment as kind of info site, global in the cloud, to have the patterns is all the
So you
content
mean
environment?
take all the customer metrics and put them in the cloud?
No. To have this for the customers which would be interested, to have a kind of analytics in the cloud, to have the right patterns on their normal environment, and maybe to help other customers because someone has already had this kind of problem and so on, and to have a big service around
The
that.
easiest way to answer that question to you is I would say that generally we don't do that. And the reason being is because most of our customers are dealing with quite sensitive data. So they don't really want to share what they're doing. But does the technology have the capability? Well, sure it does, because right now we're doing this over a web browser. So we could
That's why I ask you that.
Yeah, we
If it's
could
possible,
collect,
that's
yeah,
fine.
we could do it, but the reality is the customer base that we're dealing with, you know, genome research, scientific research, these are guys who are, their data is so important to them, that's their
No,
business.
that's why I'm not speaking
Yeah,
about the
exactly.
data, but just
To be honest, it hasn't come up yet.
just
and we
in fact all
we don't have any
the
plan yet for
monitoring
that.
patterns to.
We don't have any plan yet for that, but that'd be
Okay.
interesting to look. We're going to react to what the customer wants, and today, based on the population we've been addressing, we haven't seen that because, as Christo was saying,
They want to
some
keep
of our
it.
customers are government agencies. They don't want us. Absolutely not. Okay. So, but as we get more broader, as we're seeing that the usage pattern and the requirement of StoneX meeting more kind of the general population, probably something like that will come up, and it's something we should be looking at, definitely. But today we don't have it in our plan, to be honest.
Okay, good. Comment number 2. So let me get into the last monitoring style application that we have, and this is really our newest application. This is our utilization application, which is designed to really help our customers understand what's going on within the different tiers of data. Here we go. So we look at exactly what's on primary storage and what's on archive. Really clear view, so we've got very little volume, right, 4.04 terabytes, but this is a nice simplistic way to visualize exactly what's going on. Then, over here, we can look at line graphs of where that data is sitting. Over here, we can look at what kind of data is on disk, is it on cloud, is it on tape. So where is that data sitting, and probably more importantly from a capacity planning perspective, what's going to be happening to it in the future. So we've got algorithms that we've developed that can take what's happening in the system real time and turn that into predictive values moving forward. And you can see we can actually change this so that we can predict out from a further amount of time. And you can see up here we've got, this is a fairly short view. We've got 1 month. We can go to 6 month. And one thing I haven't mentioned yet that I think is another powerful part of StoneX Connect is we've got the ability to report out on this, right? So if you need to go, if you're inside the business, you need to do some resource planning, you need to do some capacity planning, you've got the ability to just output right out of here a report to hopefully make that decision process a bit easier.
So this was driven directly from our media and entertainment users who are trying to figure out how do you plan your budget for next year. My SSD is being overutilized, my tape library is barely used, and there's a ton of data up in the cloud. What are we going to do? How do we want to push user behavior, but also how do we plan our budgets as far as how much storage capacity we're going to buy next year? So it's been used as pretty much for budget planning tools. Really,
But history's
where
not
the
very
users
useful
use
in
it.
media and entertainment modelling, but generally.
No,
It's my
it's
trade.
predictive.
So you need to be able to do your what if modelling. So
Yeah.
you need to say, okay, so I stick a load of 4K assets in, what's going to happen if I drop that broadcaster or I drop that channel, what's going to happen to my system? So you need a what if tool. I mean, history, if we went by history,
It won't be enough, really.
you wouldn't be yet.
Yeah, let's give you a base, basically, kind of.
Yeah.
Here's the thing stay steady.
But if
Now,
you-
I'm out on top of that. What's
That's
going to
true
change?
for any enterprise. There is no yesterday, there's only tomorrow.
but
Don't
that's
tell
why
me what you
do
did
need
for me
modelling.
yesterday, tell me what you're going to do
Sorry?
for me tomorrow.
That's why you do need some form of modelling. What happens if you just take this data
Oh, yeah.
source, or
No,
this
don't
type
take
of
the
data, or
idea.
this age of data, and stuff like
So-
I
that? And
agree
if you
with
could
that, but I
combine
would
it
go
with
back
costing
to,
as well to cloud, then that would be
Yeah, I
interesting.
agree with that, but I would go back to the way the customers, CIO types have asked us to handle this is they have such a hard time seeing all the different tiers within their environment. You know, they have all these different vendors, all these different technologies. Being able to see in a single point, what do we have? How is it being used? How is it growing? Really does help them
But
more
that's
than
why
any
if you
other
had
budget
the
planning
ability
tool
to
they
say,
have.
if we click on, you change the age dates on the archiving, or if we click on different media types or different volume sources, as was said, then just show me what happens on the chart. That's the sort of thing they might find useful to play with. Because otherwise they're doing it all on Excel spreadsheets or in their head,
Yeah.
and that's
Exactly.
much
So-
harder to comprehend.
So just to be controversial, I want to give you an example of historical data and why historical storage is important, because I can give you a real customer example. So we have a customer here in the UK. They do a lot of research work, so it's medical research work. And what they have is they have different, I think the best way to describe it is faculties that basically share the storage, because our goal is to give shared storage, right? And there's a cross-charging mechanism that's used to charge for storage. And this is becoming a very common thing, because in these research organizations, they're pooling lots of different money together to buy that big system. So they're being more traditional in that they're centralizing. And storage is one of those key areas where they are centralizing. To get the charges back, they're using historical data. So there's an example
Yeah.
of historical data.
Yeah.
So
But then again,
historical
if you
data-
take somebody like Netflix, and
Yeah.
let's say that all of a sudden the Lake District suddenly gets gigabit Ethernet connectivity. So all of a sudden there's several 100,000 people who can take 4K feeds from Netflix who couldn't before. If they're dependent on what's happened in the past, it'll all go wrong.
I got it.
They've
Yeah.
got to be able to play the what ifs.
Yeah,
What
sure.
if this happens?
Sure.
But you're not going to change user behavior by looking at history. That's Martin's point.
Yeah,
Yeah.
agree,
Right.
agree.
I got it.
You change
Yeah.
user behavior.
Yeah.
You
I just wanted
drive
to
them
swing
to
it around.
smarter.
Yeah.
No, I'm not.
Yeah, in an
I was going to
ideal
say
world, you need
today
also
we
work.
only look at historical data because that's the only data we've got.
Yeah.
Our
Yeah.
vendors are only giving us buggy whips instead of giving us cars.
Mm.
You can get some historical data because you can do that really, really cheap, and it's really, really dumb to give you historical data analysis.
Yeah.
Doing predictive future analysis or what if scenarios or financial modelling on if I stopped doing 4K and tiered it down to here, this would change your cost ratios to this.
Yeah.
That's actually hard work for you.
So what you really want is a sizing tool built into the GUI.
A little, yeah.
Yeah.
Something that we can sort of
Good
sit there
point.
and go and sit with the user and say, well, look, you know, this is how much you're using. If
Good
you
feedback.
did this, we would, and that would
How much you
suddenly,
save.
Yeah.
see, you know, people don't want to use tape because they can't see the cost value of a tape drive.
Yeah.
So they never, especially in media,
Yeah.
so they never move it to tape, right?
Yeah.
It always has to be done manually after the project's terminated.
No,
Yeah.
why it doesn't. All comes down to workflow, Greg.
Yeah, work like, oh, is that right? Is that right? And,
They go feed the kids.
yeah.
Point. And Christo, you know, if the customer was really clever, perhaps they would charge those departments different rates depending on where that data exists, and if each department had its own workspace, they could make that happen. So, everyone, this is basically the monitoring capabilities of StoreNext Connect. Let me just quickly take you into the manage functionality. We've got manage clients, which is a really clever way if you've got an environment that has a lot of clients out there. It's a really clever way to go ahead and update them to see exactly what they're running. So, in this environment, it's all CentOS, but you can have Mac environments, you have Linux environments. You can see what version they're actually running. You can see the status, and in a lot of these environments, and not this specific system, you can actually do your restarts and your reboots and your upgrades right from here. So it helps automate some of that updating.
So for the clients, if you've thought about introducing grouping, so you can have a group that, say, for instance, you might have a bunch of Mac users who are, say, your FC users, so you want them to, you want to do all of them at one time, because actually, if you've got thousands of clients out there, you're probably not going to want to sit there and select the clients all at one time.
Yeah.
So you're going to want wildcarding or something like that,
Yeah.
some way of grouping them together.
Mm.
Should do something. Should get back on that. should get back to you on that. But I think we should have that.
I think you can create multiple workspaces. I think you can.
Okay, so that is the primary functionality I wanted to go over.
A few other things probably worth mentioning. All of our firmware upgrades to our hardware can be done through Connect. So if you want to push upgrades out to the cluster, to the nodes, that can be done through here. Also pulling logs from the entire environment when you do have to open a support ticket. This is where you'd go, administrator would go to pull the log files and just push them up to Quantum. So from an ongoing kind of maintenance perspective, we're aggregating that here as well versus having to download, the firmware upgrade on each portion of the cluster. And, in big environments that becomes quite onerous.
Yeah.
Is it going to manage other devices as well as quantum technology?
I don't know. That starts, that's where we had locked down just using quantum hardware so we could really control quality of service, all those different things. We've started to open up a bit, on the archive tier in particular to others, both cloud and object stores. But as far as being able to, push their management data or, their upgrades, I would expect that's a long ways away, honestly.
Swiss or something like that.
Yeah, it's more to be able to get their data into its namespace, but management-wise, I don't see us going that way for a while.
It definitely help you kind of open the management console from the object you're going to discover, but that's it.
We love each other, but not that much. We're still competitors too. But yeah, I think it's a tough thing as you move data across tiers. I mean, you guys look at all the things you could manage and report and predict on, and being able to unify and simplify it is a huge goal. It's also really complicated, even with our own stuff. So, continuing to expand that out is
the main
over
goal
time.
of Connect is really kind of, there is so much richness in StoreNext. There's so many ways you can architect with StoreNext that it could become complicated for a person that doesn't have IT and storage knowledge. We try to demystify that and make it simple to interact with the environment. Because it is very powerful. We get deployed more often in an environment where nobody else was able to address the need of the customer. So we're able to address these edge cases. But we want to also take it more mainstream because we see the needs becoming more mainstream. So we had to come with something like this that kind of demystify the complexity, simplify it, and make it more accessible. That's the objective of this.
Yeah, and going back to your world. So if you take 4K, as you know, there's multiple types of 4K. So we've even got to the point now where, from a sales perspective, we're almost creating these bundles where they are, let's say, a 4K solution. So it's this bundle, the guy can buy that bundle, and when he gets that bundle, of course, he gets the white paper associated to it, which is telling him how to implement the right box sizes, etc., etc., etc. So we try and make it more simplistic and try and address that mid-size post house, where in the past, we were only playing with the really big post houses, and that's sort of going back to your making it more mainstream.
Just the last thing that I want to kind of conclude on is that we do have NAS management and monitoring through this tool as well. So you can configure your shares, you can create your NAS clusters, and configure gateways through this tool as well. So we have basic NAS functionality as well.